Delete comment. Okay. Hello, everyone. Good
Hey,
afternoon.
Professor.
Good afternoon.
Okay. Do you see the slide?
Yes,
Yes.
sir.
Okay, good. Okay, our plan for today, we'll talk about the project. We'll deal with the project up to the end of the class. So we covered the materials, labs. So the only thing left is the project. So we'll talk about it a little bit today, and we'll take quiz 2. So this is our plan for today. If you have any questions regarding the labs, please let us talk about it after we finish, okay? Okay, so the lab, as you see, simply the project simply deal with design entry using VHDL code and schematic. And this actually used for as input for field programmable gate array. So after we put the code either as VHD language or code or drawing schematic gates. So at the end, there is a bit stream for the whole project downloaded on the field programmable gate array. As mentioned, the field programmable gate array has hundreds of thousands of gates created on the board. So it satisfies a huge number of functions and used for many applications. Among them, encryption. So this is what we are going to do today for this project. Of course, we will reach up to the phase of simulation. simulation to make sure the connection or the code we put satisfy the function of the circuit. After that, actually is done in the physical lab. And I will show you a picture for the rest, which is done in the lab. Okay. So this circuit assembly is called the light controller. The circuit here is light controller. So what this circuit does? It's like I live in very traditional house for a building, and say I live in the 3rd floor. So when I came from outside and enter the building, so there is a light. I change the switch of X1. So the light is on. So I go upstairs until I reach to my apartment in the 3rd floor. When I reach to the apartment, I change the switch for X2. So the light is off. X1 and X2 actually like switches. Okay. Connect bit 1 or bit 0. Early morning, I am going to my work. So get out of my apartment, turn or change the switch of X2, so the light is on. Until I reach to the 1st floor, turn X1 or change the switch for X1, so the light is off. So actually, this is the truth table for the function. When both the switches off, like when I came from outside, enter the building, so the light is off because X1 and X2 are 0, 0. Now I turn on or change the switch for X1, so we have like 1 and 0, the other switch is 0, so the light is on. Going up, change the switch, so we have like 1, 1, so the output is 0. Then wake up in the morning, going out of the apartment, turn 1, so we have 1, 0. So the light is on, and so on. This exactly is a function of exclusive OR circuit. But here we put it in details, like we put the components inside the gate to see exactly what happens, like the connections here. So if X1 is 1, so bit 1 goes to this gate, and the bit 0 goes to other gate. Then X2 is off. So we have 1 also applied for this gate and 0 applied for this gate. So we have 1 here. So F is 1. And so on. So this function actually, this truth table reflects the function of this circuit. And this is what we need to verify. We need to build the circuit. Either express the circuit as VHDL code, and this one part. The second part will draw the schematic of this, another approach, using the schematic. And in both parts, will verify the function of this circuit. So IEEE library, it has a lot of codes. So this code actually expresses the function of this circuit as VHDL. So as you see, like port X1 and X2 and input, output is F. The function F is output. So the function is X1 and not X2 for this gate here, X1 and not, and not X2. So this means the inputs here, X1 and X2 inverted. Or, because the output here goes to the OR gate, the other input, which not X1 or X1 inverted and X2. So this function here, it just express the Boolean function. The Boolean function, like F or Y we did before, when we put expression for F. This is expression as VHDL code. The project here, the name of the project here, please everyone focus with me, okay? The name of the project here is called Light, based on as it is taken from the library, but will it change the name? Each group will put the group number in the project. So for the example, I will show you. So we have 2 parts. So for part 1, we use VHDL. So we'll call it design. I call it design. Group 10. VH for the first part. VH for the first part, because we use VHDL or VHD code. For the second part, we'll use the name as design. And I for my example, I put G10 and SCH for schematic. Because like two parts, different names, because different techniques, but for the same example. This group number will be changed per your group number. This group submission. So this group number like will be group 1, group 2, based on your group number. For example, Joshua will put G1 or group 1 for both parts. Christian, for example, will put group 4, G4. Okay? So each group should name the project based on the group number they have. Okay?
So, sorry.
Go
So
ahead.
when you create the group, or when you create the project and
You change the name. You change this slide should be changed.
Design G1, right?
Yeah. And
Okay.
here there are 3 like here and here and here. Should be changed 3 times based on what we have here, okay? So make sure you have the same project name here at this location and here and here, okay? So
Professor,
you will just copy this and then and paste it. I will show you how, and then you change the name.
Professor,
Yeah, go ahead.
question. For the names, what are the letters for? Because for in the examples you gave us, it says design G10 VH.
Design, good. The name is design, and then group number, your group number, G1 or 4, whatever, and VH, because 2 parts we use VHD code, and the second part will use schematic. So
Okay.
one VH for VHDL code and SCH for schematic.
Okay, I see. Depending on the part, we use different letters.
Yeah,
Yeah.
I put 1 and 2 here. So
Okay.
this for part 1, this for part 2.
Thank you.
So, Professor, this is you want the schematic and the code in one project, right? And we just changed the file names.
I will show you.
Okay.
It's like one project, but actually it's separated. It's different
Okay.
names. But for the
Okay.
same problem. So the same problem we'll do it one time using the code VHD, and the other technique will use the schematic, like what we did in multisim, draw the circuit,
Uh-huh.
yeah, and then simulate. I will show you, okay? So just to follow what I'm saying now.
Yes, sir.
And this is the name of the device we use, actually. As I mentioned, this like 90% of the whole task, because after we do this and we check the function of the codes, we download this on the field program over gate array. So it's related to the FPGA we use, and this is a device, the target, the name of the device which we use, okay? I assume everyone, I mean, at least, yeah, should be, or as a group, you have Curtis 2 now, okay? Okay, so let us do that. So we click, let me just share with you. Another one. Okay, you see this Curtis 2 now?
Yes, sir.
Yes, yeah.
Okay. So first of all, please follow what I'm saying, okay? I posted the Curtis tutorial, but it's more convenient if you follow what I'm saying, okay? So first of all, we click create new project, okay? So let us, okay? Then we'll see this window here. So just next. Click next. And now we need to put the name of our project. So click here. And new folder. And put the name. I will call it now because we will do another one here. So design, I will say group 12. So the first name we mentioned, VH, okay? So design G12, as I mentioned, you put G1, G2, whatever, VH. Then select the folder, so you see now the name of the project here. And put, what is the name of the project? Just put design G12, for me, G12, VH, so you can see it appears here and here. And then finish, click finish. So you can see the name here of the project. Now we need to change this because this is not the type of our FPGA. Silicon IVG is not. So we click on this.
Oh, Professor, I don't think we can
Yeah.
see what you're doing.
What is that?
I don't think we can see the other tab, the other window you have open. Is it on a different monitor?
Yeah. Oh, okay, so why you don't tell me?
Sorry, no, I was following along, so I was looking somewhere else.
No one see it?
Can you move it to the monitor that has the main window?
It doesn't move. It doesn't move. I don't. Let me see. Maybe. Yeah, we can do that. Okay. Yeah, you see it now?
No.
No.
I see your desktop.
Yeah, we see your
Okay,
desktop.
just 1 second.
Very organized.
You see it now?
No,
No.
not yet.
Still your desktop.
Okay, just 1 second. Can you see it now?
No, not yet.
No.
Okay, hold on 1 second.
I mean, he's sharing the full screen, so I think. Oh no. No, that's the main window still.
You see it here?
We see the main window, but we don't see the project creation wizard.
Yeah. I can see Quartus.
So
Don't
what
you?
you see? What you see? You see.
We see the project.
Okay.
So like the window where you actually work in, but you're still creating the project, right?
So you say you see a portion of the screen? Oh, you don't see it now. Okay, just 1 second. See it now?
Yes.
Everyone see it now?
Yes.
Yeah.
That's what-
Oh,
Yeah.
okay, good. Okay, so click here. You see this one under the quotes? Okay. So under here, tell me if you have anything you need to say. It's okay?
Yeah.
Okay.
Yeah, I think it's good now.
Oh, okay.
Thanks.
So we click here and we choose Silicon 3 or Cyclone 3, sorry. Cyclone 3. This is the type of the device we have. Then target device, click on a specific device because we have a lot here, so we need to do like some kind of filtration and put the number or the target device I give it to you on the document. So it is EB3 C16 C16 F4 E4 C6. So you can see it here now. Okay. Then, okay. So now we have the device here, the correct one, or the one we use. Then the next step, under File, New, and you can see here VHDL file. You see this?
Yeah.
Yes.
So click, highlight this and say OK. Then File, Save As. So you have the file name here and dot VHD. And save. So you can see the file name here, VHD. I mean dot VHD. Then copy the code from here. And paste it. And we mentioned we need to change the project name. So design group 12, I think, right? And VH. Okay. And again here, design group 12 VH. And here too, design group 12 VH. Okay. Sure. Okay. After we post the code, you see this arrow here. This is for compilation. So start compilation. Yes. So running. Okay. So Verso, before you do that, you need to get screenshot for the code. I listed the screenshot we need. Okay. And then a screenshot also for you see full compilation. So this means the code is correct. If there is something is not complete, go back to the code and review it. Maybe there is any something not written correct. Okay. So okay, and then after you got screenshots, close this. And now we go to File, New, and we need vector waveform file. So you see this university program, VWF. You see this? Because we need to do simulation. You see this? But
I
you
see
see,
it.
okay. So then, okay. So you see, you get this one. Click Edit, Insert, Node or Bus. And click on Node Finder. List. So you can see the inputs and the output here. X1, X2, and F. Click on this. So this moved to this side. And then OK. Click OK. And another OK. So you can see here the inputs and the output. Click Edit and set in the time. How many inputs we have here? How many bits at the input? How many inputs?
2.
2, X1 and X2. So 2 to the power, what's your code? What's your code?
30 divided by 10.
No, your code,
3.
3. Okay, thank you. So we have two inputs or 2 bits. So 2 to the power 2 is 4. Okay, so we end the time here. We choose 4 microsecond, and click OK. Then grid size. Grid size will choose 1 microsecond. This is nanosecond. Make sure you change it to microsecond. Okay. Now we need to set the inputs. So click on X1 and under here, you see here, this override the clock. And put 4. Change this 1 to 4 here because we choose the 4. Okay. Then X2, do the same thing. Click here. So 4 divided 2, so is 2. So choose 2. and okay. So you can see the inputs here. We just put the inputs, either 0, 0 or 0, 0, 0, 0, 1, 0, 0, 1, 1, 1. You see these inputs? This logic 0, this logic high. 0, high, okay? So we have the different combinations here. We have the different combination. Please, just 1 second, please. Just 1 second. Okay, sorry about that. Okay. So we inserted the inputs, then click simulation. And when you click on simulation, choose option first. So options here, choose Curtis 2. Then okay. Okay. Then simulate. Run functional simulation. Yes. Yeah, we need to, change, put the file here, design G12 VH dot VWF. VWF. Let's see. So now simulation is running. And this is what we got. So what you see? Does this satisfy the function or not? You tell me. Based on this, the result of simulation, did we satisfy the function or not of the circuit?
I think so.
Yes or no? Yes. Why yes? Who said yes? What's up? What's 15? 15? Okay, why? Why satisfied? Tell me how. Tell me how. On the results here. Tell me how. Like here. So F is 0. So X1 0, X2 0, so F is 0. Okay. Go ahead. Like 0, 1 is high. 0, 0 is low. 1, 0 is high. What is next? Okay, yeah, because like here, high, low is high, low, high is low, like 0, 1 is 1, 1, 0 is 1, and then Like 1, 1 is 0. All right? 1, 1, similar inputs, 0 out, right? Similar inputs, 0, 0, the output is 0. 1, 1, the output is 0, but 1, 0 or 0, 1, the output is 1. So this ends the simulation. After that, if we like use just VHDL, as I mentioned, we download this on the kit, the field programmable gate array into the device, and then when we, based on the switches we use and the output we use, of course, this chosen when we download, so you can check the function physically on the board.
Professor,
Okay, any questions so far? Yes, sir.
this is the output and input waveform, right?
Yeah, this is before simulation, this is after simulation, and of course we need also screenshots for this when you do it, okay? Here's the input and the output, but before simulation. And you can see after simulation, we got the result here. Okay, it's clear? Clear, guys, or no? Why you are quiet today?
I mean, I didn't
It's
really
clear.
catch how to like do the
Yeah, it's clear.
stuff, but I'll figure it out.
What is not clear for you? What is not? What's
No,
your code?
just
Set up.
using
What is your
Quarkus.
code? What's your code?
Me?
Hmm?
3?
3. Okay, so which part is not clear? Which item not clear for you?
Just like doing all the options for the waveform. Just like changing all the options or whatever.
What options?
I don't know. I wasn't. I was on another window.
Well, I don't see the question. What is the question exactly? Where you stuck? Where you stuck?
No, I just needed to know how to open like the waveform editor and use it.
Okay. Setting the inputs is. Do you have issue with setting these inputs here?
No, I mean like I haven't even opened the simulation window yet.
Why? What? Okay. Did you when you click on simulation, did you choose options first? Because you have to choose the right one match with Curtis 2. Because there are 2 options. If by default it is on the other option which we don't use, so you have to change it to the other option. So can you click on simulation? Simulation here.
Wait, no, I'm trying to like create the waveform, like the editor when you do file new.
Yeah, file new, and I mentioned you choose the one listed university program VWF. You click on this one, and then highlight and say okay, or click on it. University program VWF. This under VWF.
Yes, I got it.
Okay. So now you click on edit and adjust the end time, but you have to first okay. You click on edit after you save the file. You click edit, save the file .vwf. Then click edit here. So you see insert, and in front of insert, you will see insert node or bus. You click on this. Okay.
Yeah.
Then click on node finder. Click node finder.
Uh-huh.
Then click list.
Ah, I see.
Then
And then okay.
on the two arrows, no, two arrows, click on the two arrows. So it will be moved to the right side.
All three?
Yeah.
Yep. All three to the right side.
Okay, good. Then click OK and another OK.
Okay. Ah, okay, I see. And then now I have to edit and then set end
Edit,
time.
yeah, click edit and set end time.
4 microseconds, or how long did you
4
say?
microsecond, yeah, because as I mentioned, we have 2 bits, so 2 to the power 2 is 4. So we choose the maximum, which is 4 microseconds.
Okay.
By the way, if we have 3 bits, so how much, how many microseconds we choose?
8.
8, exactly. If the circuit, in the circuit we have 3 inputs, so we have to choose 8 microseconds. 2 to the power 3 is 8. Okay? Then, okay, click OK. Again, edit grid size. For the grid size, we choose 1 microsecond.
Yep.
Then, okay. Then now we need to set up the inputs. So highlight on X1, click on X1, and then you see this icon here. You click on this
Icon.
override. Yeah, this one. You click on this one.
Hold on. Where?
You see this one? There is a like clock here.
Clock.
Clock override. You see this one or no?
No, I'm not seeing it.
You should have, if you reach to here, you should see this.
I can't see your mouse. I see overwrite clock.
Yeah, this
Override
one.
clock.
Click on this.
I see. Okay, I got it.
Okay.
Click overwrite clock on
Yeah.
X1.
And then choose the period 4 microsecond.
Period 1 microsecond. Okay.
4.
Oh, 4.
So you should get this pulses here.
Yes.
Okay, perfect. Then click on X2 and go do the same thing on override. Click here and choose 2 microseconds. Like we divide the 4 by 2, so we get 2.
Okay.
So you will get this. Okay.
Yep.
Micro, 2
Okay.
micro, not nano. Because I think by default it is listed nanosecond. Change it to micro. 2 microsecond to get this one.
Yeah, I have my thing matches yours.
Okay, good. Then click simulation.
Simulation.
Then choose options.
Options. Cortis 2 simulator. I remember that.
Yeah, choose the other one. Yeah, Curtis. Okay. Then go back to simulation. Click on simulation again. And choose run functional simulation.
Mm-hmm.
So you should get this one. Got it? Oh, it takes some time, take few minutes, like 2 minutes or so.
Okay. Okay, that's good then. Thank you.
You got it? Perfect.
I'm still waiting for it, but yeah, I understand what to do now.
Okay, good. Okay. Any questions, guys? So let me show you a photo for the rest if we are in the physical lab. You see this like if we are in the physical lab. But this is another project, but the same thing. You see, let me show you first before this, the board again. Yeah. This is the board. This is FPGA. The type we use when we put the target device EB3C. This for this device. I mean this number for this device. You see the switches are here. The switches are here for the inputs. So like X1 and X2 for the photo I show you, we choose like the first switch here for X1, the second switch for X2. And then the lights are here. So for F, I choose the first light. Okay? And you see the whole thing here, hundreds of thousands of gates here, a processor, everything. So just based on the circuit you draw or you put the code, just at the end you check the function based on the inputs, and the inputs means the switches you choose, because we have many switches here, and also the output you choose, the output light. We have a lot of lights here. So for this one, I choose the first and second switch for X1 and X2, and the first light for F. Okay. So you can see here, the light is here for F. So this is how it looks like. Okay. Okay. So any questions, guys? Any questions? So this for the first part. And next time we'll do the second part by drawing the schematic. Drawing like similar to we draw the circuit on multi-cell, but here we'll do it in this software. And again, we'll do simulation and see does the simulation satisfy the truth table or not?
I just have a question.
Yeah, go ahead.
On the document, it says we need to include the screenshot of the full completion statement. What do you mean by that?
Yeah, when you do this compilation, just typing error. When you run the code, like as I mentioned, click on the arrow. So this combination. So this gives you your code is correct or there is error with that. And a small window appears, says complete, compilation is complete, or we saw this. So when you run the code, After you paste it and you change the project name, and there is arrow in the top, click on the arrow for compilation. So this check if the code is right or not. In schematic, this check the connections are correct or not. So if everything is correct, it gives you complete compilation. So this is what I mean to get screenshot for that.
Okay, and for the input
Input
waveforms and
waveform,
output waveforms, I know what they are, but I thought, aren't they in the same window? So I think one screenshot is enough to capture
no,
both waveforms, right?
can be two different. I mean, input waveforms. This before the simulation.
I see. It was
Output
before and after
waveform,
simulation.
another screenshot, because you may not get the output waveform for any reason, simulation, whatever. So just to get credit for at least one of them. Okay.
Got it.
Okay.
Yeah, thank you. And Gabriel asked a question in the chat.
In the chat, because yeah, okay, let me see. See. As I mentioned, this group submission, you should work together and review the project before you submit. Is not just one work on this and submit. This is not teamwork. Teamwork, everyone participate, and there is a percentage for each one determined by the coordinator, and all you exchange whatever you got. If you don't have a chance to meet or whatever, you still communicate with different ways, such that you submit after you agree about what you got. Okay, so is one submission, but of course you work as a group. Okay, Gabriel, does this answer your question or? Okay, any other question? Okay, so if we don't have questions, so we do the quiz. Okay, so let us take like 5 minutes break, please, and I will post the quiz. Okay, just 5 minutes break. Okay, guys, you can start now. Okay, go ahead. Good luck. Please make sure you submit before 4:20. It doesn't take much time. It's easy exam. If you have any question, please let me know. Nermin is here. Nermin. Belgian. David. Joseph.
Thanks, Professor. Have a good weekend. Professor, so sorry. I just realized when I downloaded the quiz, the second page was corrupted or something and didn't show up. And I just double checked on Canvas and saw the second page. Is it all right if I had already submitted the assignment? Is it all right if I continue on and then email you with the actual second page solutions? I'm sorry, Professor, I can't hear you.
Well, what is the issue?
When I downloaded the quiz, the document for the quiz, the second page was corrupted and didn't show up. And so I thought it was only the first page. So I did all the answers to the first page and then submitted those online. And then just realized that I had forgotten to do the answers for the second page.
Chat with me, please. Chat with
All
me.
right, thanks.
How do you see the second page? I also can't see the second page.
Wilton, chat with me, Wilton. Riley. The quiz 2 pages, guys. And I put beside the quiz at the top 1/2.
I can't see the second page, Professor.
What do you mean you can see the second page?
Like when I try to scroll down, it shows one page. Like there's no second page in the document. I see the 1 out of 2 that you're talking about, but there's no like 2 out of 2.
Just 1 second. Everyone hear me? Do you hear?
Yes.
Okay.
Yes.
Yes.
Okay.
Yes.
Let me double check. Do you see the second page, guys, or not?
I see it.
Yeah, I do now.
I didn't change anything. Please review everything and make sure you didn't miss anything before submission. Okay?
Thank you, Professor. Have a good weekend.
You too, take care. Bye. You should submit now, unless you need more time. Because if you wait to 4:20, the system will not accept your task.
Hey, Professor. I think I need more time.
How much time you need?
I need like 10 minutes.
Okay.
Thank you.
Mm-hmm. Okay. I will add 15 minutes. Okay.
Thank you, Professor. Have a nice afternoon.
You too. Take care. Bye.
Thank you, Professor.
Thank you, sir. Bye. Two pages. Okay. I, let me double check. Okay. Just one second. Yeah. Yeah, just 4 questions. Yeah. 4 questions. You're welcome. Take care. You too. Take care.